So I've just squared this block up. That's all so far. I wanted to take some measurements off these V-ways, but I don't have anything that will rest on them satisfactorily. This is a 90-degree V-block, obviously too big. I've measured this as best I can, and I think it is 70 degrees. So I did search for 70-degree V-blocks, but I couldn't find any. So I'm thinking I'm going to have to make a V-block to fit on there. I think the correct way to cut a V-groove would be to use a horizontal milling machine, as shown here in a clip from one of Keith Rucker's videos. He's actually setting up to cut gear teeth using this cutter here. But if one used this setup with this kind of cutter, it would cut a V-groove. But I couldn't find one that had a 70-degree angle. Also, they're rather expensive. I could use a cutter like this on an arbor in my vertical mill, but it wouldn't be anything like as rigid as this setup, which has a support at both ends of the arbor. So I ruled out that as a way of doing it. Of course, if the included angle of the V is 90 degrees or more, one can mill it directly like this. But that doesn't work for angles of less than 90 degrees. I've got various countersinks, but none of them have an included angle that is less than 70 degrees. So, for example, if we take this one, this would not work in there. It's going to hit. This must be that one. That's about 80 degrees, that one. So I bought this solid carbide mill. This angle is 60 degrees, so it's 30 degrees slope on either side. I actually wanted an HSS one, but I couldn't find one, so I had to buy the solid carbide one. This is 1mm depth of cut, because I don't want to break this 4mm end mill, so we're just going to take it slowly. I've encountered a slight snag. This is the first time I've wanted to use this swivel facility on this vise, and I find that I can't because this hits the top of this nut. So I'm going to mill the top of this nut off. How much? Now what? Oh, this one's clearing now, but this one is still hitting, so I've got to take that off. This is a 5-degree angle, so if I put it like that and put this, I've only got one 5-degree angle, unfortunately, which is a bit of a nuisance. I'm hoping that is at 5 degrees. Well, I reckon that's lined up with this, with that edge. So this should be cutting at 30 degrees to the vertical, and this is tilted at 5 degrees, so it's a total of 35 degrees, which is half 70. So if I just plunge this down and cut backwards and forwards, I should be alright, shouldn't I? Seems to be working okay. Starting to cut on both sides of the groove now. I'm hoping that doesn't matter, just makes life more difficult. Of course, as I plunge it deeper and deeper, the amount of the tool engaging with the workpiece is getting larger. Of course, I'm using aluminium here as a test, a feasibility test. It should really be made out of something that can be hardened, but not until I've got some experience. Right, that's as deep as I can go, which is 10.5mm from the top. Nice finish. What I've got to do now is turn the workpiece around and do the same thing on this side. Right, so take this off. Just put it back like that. So, since the original slot was in the middle this way, I reckon that this should be alright. We've already cut some of it, so let's go down to about there. On we go. Nearly there. Right, final pass. Should be it. Well, it looks nice. However, I've gone just a little bit too deep, because you can see that there is a slight vertical edge on each side here. So I'm going to have to remove that. What shall I do? Looks to me as if I've got to mill this down by 1 millimetre now, because I've gone too deep. Right. Come on, I know you're in there. So the acid test is, does it actually fit on here now? I think it does. Yeah, I think that's as good as could reasonably be expected. I'd have liked to have made that V deeper, but of course the that carbide end mill isn't long enough to make it deeper without without difficult operations. These very fine chips that the carbide end mill made, although they're only aluminium, are surprisingly sharp, and it's quite easy to get them stuck in your hand. And they're also difficult to clean up, given that they've got sort of WD-40 sticking them to everything. This is interesting. If I put this inverted V on this end of the V-way, which is the tailgate end, where it's least likely to be worn, it seems to fit well. Obviously I can tilt it like that, but if I just hold it down, it doesn't rock at all, right? Now if I do the same thing here, which is the area it's most likely to be worn, can you see that rock? Now the reason for that is that the saddle does not rest upon this part of the ways at the top here. It rests lower down. That's why you can see a kind of line, although I can't actually feel it with my fingernails really. There's a kind of a wear line along here where this stuff at the top is not worn, whereas this thing is resting partly on that unworn top bit. So if I want to reproduce the experience of the saddle, what I need to do is widen this V slightly so that it sits a little bit lower down on here, not engaging on this bit here. That's my thought. This is a saddle, and I haven't done anything to it since I took it off the machine. It hasn't been cleaned up at all. So this is actually upside down, so this sits on the flat way and this sits on the V way, and if you look along here, of course that is the bottom, isn't it? That's the bottom. It's the top bit that I want, that I'm concerned about. It would be this bit here. It doesn't look, it looks kind of as if it's not worn right at the bottom, but worn all the way up to the apex. So maybe my theory wasn't correct. And if we look at the other one, the other side, there, so we're looking at this side here. So I suppose you could say that there is a sign there that that bit is not worn. Yes, so maybe I am basically correct. If we look at the gap between the two sides at the top, 2.86. So less than the gap in the V block that I made. So I don't quite see why my V block doesn't sit lower down than this one does, since we've got two sloping sides at the same angle with a different gap, a bigger gap I have than they have. Of course, by using an inverted V, I've essentially got two plane surfaces rubbing over each other, which is exactly how the saddle works. But there are other ways of resting something on a V-way, like, for example, taking two dowel pins and fixing them in some kind of frame like that, a fixed distance apart, and they would then rest on the V-ways and would, instead of forming a surface flat to flat contact, they would form a line contact, the point of contact between a plane and a cylinder. that would measure it would measure the width of these V-ways at a specific height more precisely than this, which is measuring, kind of averaging out the effect over the whole width of the V. What is best, I don't really know. Richard King is the American bloke who gives scraping classes, and I understand that his father designed this thing called the King Way aligner for measuring between flatways and V-ways. This is a clip from a Keith Rucker video, shows him using the device, in this case in inverted V-ways. And you see it's got a cylinder with the ends of slightly larger OD than the central part, and with a slit along it. So it just sits in an inverted V, in an ordinary V-way, and makes a line point of contact, rather like my dials would have done. But it appears that you can also rotate it the other way up to make it sit. In this case it seems to be sitting on a dovetail, but you could rotate it further to make it sit on an inverted V-way such as I have. So maybe I should make something like that. I don't know. I can't tell you how nice it is not to have that lathe blocking the middle of the garage here. I've got the headstock up from where I've left it for several months since I took it off the lathe, and I'm cleaning that up. That's the next thing I've got to do.